Hello and welcome to this third installment of the How Far to That Star series. Today we're going to be looking at something called parsecs. Do you know what a parsec is?
What is it? What is it? What is it? What is it?
So in our last video we were having a look at Parallax and the system, the method that is used for working out how far away stars are, where you measure the angle to a distant star. Now, something that I glossed over last time, I just want to draw your attention to this section of the video here. This star is closer than these stars here. These are very, very distant. And parallax only works because we're dealing with sort of medium distance stars, or actually the closer of the stars out there, because the closer a star is, the more it appears to move. The whole reason that parallax works is because things that are closer move more than things that are further away. The things that are really far away don't appear to move at all. So parallax only works if a star is sufficiently close for us to measure it moving at all. But in terms of how far it moves in a 6-month period, the angle here, the parallax angle, we're not talking about angles that are the size of 10 degrees. That if something was moving 10 degrees, that would be, planet size. That would be, the distance of a planet. That would be way too close for a star. We'd never see a movement that big. In fact, we'd rarely see a movement of a degree. We see movements that are much, much smaller, really, really minute movements. In fact, they're so small that we have to define a new system of angles just to help us to describe it. So these are sub-angle measurements, and the way that we do this is that we say we're going to split 1 degree up, and we're going to say that in 1 degree we say that there are 60 arc minutes. So it's basically we're dividing up a degree into 60 parts, and we can split that down again, and we say that each arc minute contains 60 arc seconds. So, therefore, in 1 degree, there are 60 lots of 60 arc seconds in 1 arc minute, 60 arc minutes in 1 degree. That works out as there being 3,600 arc seconds in 1 degree. So this is a system that astronomers use for dealing with changes in degrees that are 1,000th the size of a degree. Why do we bother doing this? Why bother? The question we've stumbled across before.
Why bother?
Because we have to. Because stars only move a tiny, tiny amount. Or they only appear in the sky by parallax to move by tiny fractions of angles of degrees. So this is a new system of units that we use. It's the equivalent of saying, why are we measuring distance in millimeters when we could be using kilometers? Well, kilometers is fine. Kilometers works when we're talking about the size of a country. But if we're measuring how large is a hair, or if we're measuring how large is a human cell, we need to do it in smaller units, millimeters, or even smaller, micrometers, or whatever. So we have to do this because the angles that I am moving in are so small. It's also useful for us to define a unit of distance called the parsec. And the parsec is the distance that you will get for a star whose angle of parallax is 1 arc second. Now notice here it says 1 second, that's 1 arc second. So that is 1/3600th of 1 degree on your, in terms, when we talk about 360 degrees in a full circle, well, if you have 1 degree, this is 1/3600th of 1 degree. And this parsec is useful as an astronomical unit. So now when we're dealing with parallax, we don't deal with angles, we deal with arc seconds, and we don't deal with parsecs, we don't deal with meters, we now deal with parsecs. Alright, now if we were to work all this out, what we find is that 1 parsec is equivalent to 3.1 by 10 to the 16 meters, which is on a similar sort of scale as our light years. So these are huge amounts of distance, or huge distances, and the reason we do this, because it's easier for astronomers to deal in these large units, and it's easier for them to deal in these small seconds. So these are the tools that the astronomer uses. They've got no need for using kilometers, because a kilometer is way too small, it's not impractical. They've got no need for using whole degrees, because they're way too big. If you're doing parallax, you need arc seconds and you need parsecs.
Now it's time for our wrap-up. Let's give it everything we've got. Ready? Begin.
So if we now go for our definition of a parsec, is the distance from Earth to a star of parallax angle 1 arc second. And there's a formula that is handy for us to use here. There is an inverse relationship. If you have 1 parsec, you can do as 1 arc second. So if something was 2 arc seconds away, also let me explain this. The number of parsecs away that a star is, you can find by doing 1 divided by the number of arc seconds. So for example, if we had something that was 2 arc seconds away, well, that's how far is that away? It's 1 over 2 arc seconds, which is equal to 0.5 parsecs. So the larger the angle, the smaller the distance. And that makes sense. If you've got a large angle here, if you've got a smaller angle here, then it's going to be further away. So if something had a half an arc second, then that's 1 over half an arc second is equal to 2 parsecs. And I know you thought we were just about to wrap it up, but I've got some questions for you to solve. So pause the video on these and please try and solve them. And in a few seconds I'm going to put up a screen that shows you the answers and how to solve these. I'm not going to go through them in painstaking detail, so stop it now if you want to try them, and then in 5, 4, 3, 2, 1. Here we go. To find the distance in parsec, you need to do 1 divided by the number of arc seconds. So for example, question number 1, what's the distance in parsec? Well, it's going to be 1 divided by 1/10. So the number of arcsec is 1/10 of an arcsec, so the distance is 1 divided by 1/10, which is 10. Question 5 here, what's the distance? It's 1 divided by 2 arcsec, 1 divided by 2, 0.5, and so on. And there you go, that's how to do them. And there's some answers.